Chapter 1.5, Infinite Limits, Day 2, Asymptotes and Their Properties. As we discussed yesterday, the limit of a function as it approaches c equals infinity is a vertical asymptote. And we also discussed yesterday how you can also kind of look as a shortcut when you're dividing two functions and the top is 0 or the bottom is 0 but the top is not. And again, the qualification here is that the top and bottom had to be reduced, meaning your common factors were gone. So if it was 0 over 0, it didn't count. You had to do some algebra to reduce it a little bit. And those were asymptotes. So what we want to do here in this lesson is find some vertical asymptotes using the property the bottom is 0, but the top is not. All right, so let's look. Let's find some of these vertical asymptotes. So this function should look familiar. It was in yesterday's video. We want to find a vertical asymptote here. So what we're going to do is what makes the bottom 0. That's x equals 1. And this double check. Does it make the top 0? 2 plus 1, is that 0? It hasn't been for quite some time now. So I'm going to say that x equals 1 is a vertical asymptote. And by consequence, or by definition, the limit as x approaches 1 from either the left or the right, one of those should equal infinity. And I believe it was from the right equaled negative infinity yesterday. It doesn't matter specifically. The bottom is 0, the top is not, so it's an asymptote. Okay, take a look at this one. Is there anything that makes the bottom 0? Well, if we take x squared plus 4, set it equal to 0, we got x squared equals negative 4. What can I square to get a negative number? Well, squaring means number times itself. A positive times a positive will give me a negative, or a positive. A negative times a negative will give me a positive. So there's nothing that'll make the bottom 0. So there are no vertical asymptotes. There's no place where this function approaches infinity. All right, let's take a look at this one. F of x equals 1 over x plus 3 to the 4th. We just got x plus 3 in there 4 times. I don't need to check each one. Checking x plus 3 once will be sufficient. So x plus 3 equals 0 at x equals negative 3. There's no way the top will be 0 because it's always 1. There's no variable up there to change it. So x equals negative 3 is a vertical asymptote. And so that means we're approaching infinity or a negative infinity. In this case, because this is a positive number, we're approaching positive infinity from both the left and the right. All right, let's rewrite this. Tangent, that's the same as sine over cosine. Okay, where is the bottom equal to 0 here? All right, at sine, oops, sorry, at theta equals 0, and at cosine theta equals 0. All right, well, where is cosine equal to 0? If you remember from a couple of days ago, the discontinuities of cosine are none, but the zeros of cosine are the same as the discontinuities of tangent. So that's at pi over 2 plus every half circle pi k. Now, we got to make sure they don't make the top 0. Does 0, when I plug it in the top, make it 0? Well, yes it does. And if you remember, that, the limit of that is equal to 1. So 0 is not an asymptote. But the rest of it is. And finally, we're looking for what makes the bottom 0 but not the top. Well, x equals -1. If I stick -1 into the top, do I get 0? You sure bet I do. -1 squared is 1. 1 minus 1 is 0, so I get 0 over 0. So I need to factor just to double check. Remember, 0 over 0 doesn't mean we're done. It means we have more work to do. So as I factor that, I get x plus 1, x minus 1 over x plus 1. Cancel. Now, is there anything that makes the bottom 0? Well, there's no bottom. So there's nothing that makes the bottom 0. So there's no vertical asymptotes. This would be an example of a hole in the function or a removable discontinuity. So in conclusion, when you're looking for asymptotes, what makes the bottom 0 but not the top when the function is reduced?